This is a PDP-1144. It is the last non-LSI PDP-11 ever built, which means the CPU takes up like 8 cards, but I want to push this PDP-1144 as far as possible. I want this to be the coolest 1144 ever built. In order to do that, we've got the floating point option in the CPU. We've also got the commercial instruction set option in the CPU. This is a pretty rare combination of boards. And we have enough boards to push this thing out to the full 4 megabytes of memory. But that alone is not enough to take this thing to the next level. To do that, we're gonna bolt on a FPS 100, which is a SIMD or single instruction multiple data vector processor add-on that will take this thing up to 8 megaflops of supercomputing performance. But even that's not enough because we're gonna bolt an FPS 3000 to that FPS 100, which is a MIMD add-on for the FPS 100 that's gonna take this entire thing up to 26 megaflops of early 1980s supercomputing awesomeness. This thing is gonna be a powerhouse. But there's one thing that I haven't mentioned yet, and that's storage, like getting a hard drive and some kind of removable media on this thing. And this is like the most basic thing. People have been putting hard drives on PDP-11s for decades, but every time I've tried it, I've just come up short. It's been like a war of attrition that I am decidedly losing. So today we're gonna wade back into battle and try to get some kind of storage working on this PDP-11. Initially, I was thinking I would use a Fujitsu Eagle with this machine, and the Eagle that I have is healthy. It does spin up and load the heads and go ready. But there's two big problems with this. The first is that I don't have a Unibus controller card that can go with that Eagle, and despite searching for months, I can't find the correct controller card to go with that Eagle. But the other problem is that, well, once we put the FPS 100 and the FPS 3000 in this case, there's not enough space for it. With both of these coprocessors in here, the only room that we have left for fixed storage and removable storage is this tiny little 3U space right here. So we gotta go small. We gotta either have a 5¼ inch hard drive or an 8-inch hard drive. I don't have any 8-inch hard drives, although my buddy Coley is shipping one down, so that's something that we're gonna dig into in the future. Coley's package arrived while filming this episode, so let's go ahead and open it up. I've cut the tape already, but I haven't actually looked inside of this thing. Oh my Lord. This is a Memorex 214, otherwise known as a Fujitsu 2312, I think. It is an 8-inch SMD hard drive that should be compatible with our Emulex SC12. So this is a hard drive that we can use, except that it's also unhealthy. But there are schematics for the PCBs in this thing, so we can get it fixed in the future. But we still have to get removable storage on here as well. And I was thinking about an 8-inch floppy drive, but I don't know, I really want to do some mag tape work on this. And it just so happens that I have a TU58 tape drive that can directly interface with the CPU on this 1144. And that's what we're going to work on today. This is my TU58 dual tape drive. Although I think this one was originally intended to be used with a VAX 11730 because it has one drive that faces forward here, and then it has another drive that's facing sideways back here. And I think you would put microcode in this one that stayed sideways, and it would just live there the entire time. And then the one on the front was your typical removable storage. So I don't know, maybe we're gonna pull these drives out and try to get them side by side, or maybe we'll just eliminate the sideways one, or I don't particularly know where we're going with the physical side of this build, but the reason that I'm pretty amped up about this TU58 drive is that this communicates with the 1144 CPU directly via serial, which is an incredibly simple protocol and also means that we can bypass this completely and just run a RS-232 to USB and run a TU58 emulator. Now, I do not intend to run a TU58 emulator perpetually on the machine, but That means that we can load up images rapidly via the emulator to move files onto and off of a hard drive once we get a hard drive installed. And then we can have actual deck tape 2s here in use for our removable storage. And these hold about, I think, 256 kilobytes. Unfortunately, they're all bad because the rubber band inside of these has broken on like every single one of them. So we've got to do some deck tape 2 restorations, we've got to do some TU58 restorations, and we want to get the emulator up and running on that machine. So we got a lot of work to do this week. I don't know if we'll get it all done, but we're going to give it our best shot. Let's get these tape drives out of this enclosure. And the first step is getting the PCB out. The drives connect via 2 wide connectors, and the PCB was already missing its mounting screws. So it's completely free after doing that. The front-facing drive looks like it's held in with 4 screws, 2 on each side, but after removing all 4, I tried to break the drive free from its cage and it just wasn't having it. So time to lean on my age-old ethos when working on cars. Keep removing stuff until the part you want falls out. First up is the bottom panel. It's held in with 4 screws. With that removed, it reveals the motors of the drives, and looking closer, there's a rat's nest of wires. So let's remove the rear power connector and rear ribbon cable connector. Then this crossbar with a single screw in the center is what connected the back of the drive to the sides of the case. And finally, looks like we've untangled enough wires and junk that the front-facing drive can be pulled free. Now that it's mostly out of the way, let's get that rear drive free. It's only held in with 3 screws, 2 on the front side of the drive and a third one in the back. With all 3 removed and the other drive out of the way, this one pulls free easy peasy. And there we go, both drives free and on the table. They're surprisingly simple looking drives too, aside from this gnarly encoder wheel on the bottom of the motor, that is. Everything looks in good shape except for the capstan. It's held in place with a grub screw, and after loosening that up, it can slide right off the motor shaft. The original rubber on the capstan is so perished, it just peels off with minimal effort. This stuff is gross. I'll use my increasingly dull X-Acto blade to scrape off any rubber or glue residue, and then I'll move over to a Scotch-Brite pad to really clean the aluminum up. Finally, we need to get something on the aluminum that will mimic the original rubber. I found this vinyl tubing at the hardware store that looked like it was the perfect size. I'll just slice a little piece off, then push the aluminum bit into the piece I sliced off, and there we go. Nice new little capstan. Now it's important to note that this doesn't actually push against the magnetic tape, it pushes against a rubber roller within the cassette tape itself. The last step is to grab a good chamois swab, soak it in alcohol, and give the heads a good clean. And speaking of that tape, these all have bad drive belts inside, so let's fix that right quick. The tape is held together with either 4 or 2 screws depending on when the tape was manufactured. Someone also put a label on this tape that wraps around from top to bottom, so I gotta slice that to get the tape open. And I pulled this one apart upside down. Oops. I got lucky though, the tape didn't come completely apart when I did that. On the inside here, the belt follows an interesting path. It loops around the bottom rubber roller that the capstan of the drive presses against. Then the belt squeezes in between the 2 tape wheels, pressing against the magnetic material directly, before looping around both rubber rollers in the top corners. And the original belt in this drive has just completely fallen apart. I'll try to peel it free as carefully as possible, but it's awfully sticky and may be pulling magnetic material with it. At any rate, let's get a new belt in place. I'll use these Plastibands, which seem to work really well. Though make sure you get the 4 1/4 inch ones and not the 2 1/8 inch ones. Then it's time for an incredibly fiddly battle to get the Plastiband on. I did this in one take, and you can see just how awkward it is to try and get it into all the right places. Eventually I got it all routed correctly though. The tape drives physically have cleaned up very nicely, so it's almost time to start putting things back together. But before we do, let's take a look at this main control PCB here, because there's a lot of interesting stuff going on. This is effectively a computer in and of itself. It has a full 8085 microprocessor on it with 2 kilobytes of ROM that's in this socketed IC over here, as well as 256 bytes of RAM. Then there's an 8155 that is the primary I/O controller for talking to the drives, and then there's an RCA 6402 UART. It's pretty much a computer. The only thing that's preventing us from hooking a data terminal up to it and just like running WASMon is the code in this ROM is set up specifically to do tape drive stuff. And there's also a lot of like analog control circuitry over here. Now, because this thing is absolutely RS-232 compliant, it needs to have plus 12 volts and negative 12 volts on it. And our primary power connector over here is effectively just receiving plus 5 volts and plus 12 volts. So they have a full-on charge pump that generates the negative 12 volts necessary for our RS-232 communication, which is good because that means all we got to do is supply plus 5 and plus 12 to this thing, which an ATX power supply can do. Also, there's a bunch of wire wrap jumper connectors over here. These particular ones are setting the baud rate, which sets it for 38.4, which is booking. That's pretty quick. And then these ones over here are setting up how our transmit works. And I'm pretty sure that these just go straight through for RS-232 output. But otherwise, this PCB looks surprisingly clean. I think we can plug some power into it and hook the drives up to it and see what starts happening. All right, first proper smoke test. I'm not really expecting it to do a whole lot, except for maybe this red LED to come on right here. So let's flip the switch and find out. Well, the red LED came on. The motors didn't move, but I wasn't necessarily expecting them to. Nothing went up in smoke. All right, let's get this thing back together. The PCB folds right over and one side slots into a dedicated space. Then the other side is held down with two little screws. I want to get this TU58 drive mounted in the machine today, and looking closer, there wasn't enough room to build a new case with the drives side by side, so we'll just rock it as is. I want to mock up where it's going to sit next to a hard drive and behind the front panel. Now, I'm using a Finch drive for mock-up here because the Fujitsu drive is just slightly too tall to fit in here. It ends up hitting the lateral support of the rack. That support is going to need to be either removed or modified, but we'll get to that in the future. Let's pull the shelf out so we can start punching holes in it. Once it's on the bench, I'll set the TU58 drive on and get it aligned. I want to center it in the right half of the tray, which worked out to be just about 10 centimeters from the edge. Then it's time to break out the drill and punch some holes. I'll drill 4 mounting holes that align with the TU58. Then I'll countersink each one so the mounting screws sit flush on the bottom. Next, I need to make a little front cover plate to really finish it out. I found this aluminum panel in the scraps bin, and I think it'll work perfect. It's a little too wide though, so I'll make some marks where I want to cut it, and then I'll jump over to the metal shear, which makes really quick work of cleanly cutting this thin aluminum. Now that I've got the width sorted, I just need to clearance out a section for the tape itself. I'm just holding it in place and making some quick marks. Then I'll use the jigsaw to make the vertical cuts, and I'll use metal fatigue to make the horizontal cut just by bending it back and forth. With it cut to the right size and shape and mounting holes drilled, I'll go over it completely with a Scotch-Brite pad to scuff it up. Then it gets a nice coat of semi-gloss black. While it's out there drying, let's get the power supply mounted. I'm using this Corsair ATX for now, but this won't be able to power the Fujitsu hard drive. So in the future, we'll have to build a new power supply with Meanwells. For now though, this will get the job done of testing the TU58 in situ. Next, I want to make a little panel that holds a switch and a DB25 port. But both of those require rectangular holes, and I hate trying to cut rectangular holes by hand. So I fired up the mill and figured I'd just mount them to a piece of PCB, and that looks so much nicer than anything I could have pulled off by hand. I drilled 3 holes in the shelf, ran long screws through, and tightened them down with lock nuts to make some mounting studs for the PCB. All mounted up, and that looks almost professional. I am very happy with that. What I've done here is I've interrupted the send and receive lines that go to the PDP-11. Those come into the center common on this switch, and then one side of the switch goes to the DB25 and the other to the TU58. This way I can rapidly and easily switch between an emulated TU58 and the real deal. During all this, the paint on the front panel fully cured, and boy howdy, does that look good. The TU58 plugs into the console interface card on the backplane. I'll pop the card out, and you can see there's a dedicated port on here labeled TU58. With the TU58 plugged in, let's slide the shelf all the way into place, and I'm going to need a data terminal to hook up to the 1144. I recently got this Bunker Ramo terminal from my brother who rescued it, and it is super cool. I love the aesthetic of this thing. I'm also going to need a modern computer for the TU58 emulator, and finally, let's flip that switch and kick the 1144 on. We've got the 1144 on, the TU58 is installed, but I have the switch flipped to the external DB25 port. That's because the first thing that I want to do is try and run a TU58 emulator on it. Now, I worded that to make it sound like this was the first time I was going to try and do this. I spent 6 hours earlier today trying to figure it out, and actually enlisted the help of a lot of really smart people over on the Discord. And I think we figured out the correct incantation and the correct wiring and everything like that. So this should hopefully work. I have my Linux laptop booted up here, and in the correct folder, we're going to be running an emulator called TU58FS. So if I just do /TU58FS, it's going to give me a whole bunch of information about all the different parameters and stuff that we can punch in on this thing. It's a lot. So it's a good thing that I spent that 6 hours learning the correct stuff to write down, because I think we've got it figured out. So the first thing we're going to do is we're going to do sudo sudo. This makes me a super user and allows me to access the serial port on this. And then we're going to do a /TU58FS. And then we're going to start with the parameter -p, and this is going to tell it what device we want to use. And the device we want to use is /dev/TTY-USB0. This is my plug-in USB to RS-232 serial converter that's now plugged into the DB25 port over there. The next one we want to do is -B. This is going to tell it the baud rate, and the baud rate is 38400. We've double-checked that the cards in the CPU are set for 38400. They initially weren't. They are now. So that's the speed that everything is going to be running along at. Next, we need to tell it what file we want. We do that with a -D. We want that file to be mounted to drive 0. And we want this to be a read-only file, so we're going to do an R. And then the file is 1144_1.dsk. Now this is just XXDP diagnostics thing. It was just a disk file just to prove that the system works. We're not actually expecting to do anything substantial here. So I'm going to go ahead and hit enter on this. It's going to ask me for my password, and I'm not going to tell that to you guys. And then it says emulator started, and I'm going to hit D to toggle debug so we can see a lot of information here. And we can see that there's a whole lot of dots to the left of a timestamp, and then it says unit 0 sync. The dots to the left of the timestamp are it sending bytes. So it's actually sending out a sync byte to the PDP-1144, hoping to initiate communication. Now, in order to initiate that communication, we're going to reach over to the 44 here. We're going to do B space DD. This is the built-in TU58 boot ROM. If I hit enter on that, we should see, yeah, there we go. That's so cool to see. The emulator is now filling just packet after packet of data into the PDP-11. We can say it says booting up XXDP-XM extended monitor. And there we go. We're in XXDP. It just loaded from an emulated tape drive. That's awesome. Now from here, we can type a directory to get a directory listing. We can see that the tape is dumping all sorts of extra data over to the PDP-11. There's a lot of communication that goes on between the DAPE and the 11. This is really cool. So all of our XXDP diagnostics are right here on the end. KKAAB0, for example, is a diagnostic. We can just do run KKAAB0, and if I hit enter, we can see again the tape starts dumping data over to the PDP-11, and it should respond here in a second that it's actually running. Yeah, end of CPU extended instruction set. So whatever test that is, it's like it just is sitting here running on loop and finishing forever. Now the real ticket here is not to run off of the emulator. I mean, this is like incredibly powerful, and I'm so glad that we have this set up because we're going to use it a ton in the future. But ultimately, we want to run off of a real tape. Now there is a problem here, and that is that of all of the deck tapes that I have here, even though I've replaced the rubber bands on some of these, the original band that pulled off, I think removed a bit of magnetic material with it. So these all may be ruined, and we can't even verify if they're good or not because these are all meant for a VAX. There's nothing that the PDP-11 can do with this, but we can give it a shot here. So I'm gonna hit Control P. This is a break command over to the PDP-11. And then I am going to do an H to halt the CPU. I'm gonna reach over and flip the switch. This puts it into real deal TU58 mode. And then I'm gonna hit B space DD. I don't actually know what this is gonna do. I've never actually tried this. We didn't get this far. I'm hoping to see it spin the tape at the very least. So let's hit enter, and red light on, tape is spinning. Oh, well, all right, it didn't spin very long. And I never really expected it to find anything on that tape to run. The tape that we had in there was this tape, and this tape says VAX Fortran version 4.5 on it. So this being a PDP-11 never had a hope of finding any useful data on this tape and running it. So my theory is that the TU58 woke up, spun the tape around a little bit, said, yeah, that data all looks like gobbledygook, and then just gave up. But we do know that the CPU here is happily reading in data from a TU58 because we're able to emulate it. So that is awesome. We know that the CPU is uber healthy on this. And I think that our TU58 drive is healthy as well. The only problem is that while I do have a ton of these deck tape 2s, they're all for the VAX. So while our hardware is doing good, we don't have any media that we can use, which means it sure would be nice if we could hook the emulator or the laptop up to the TU58 directly and write data down on a tape here. But I don't know how to do that. I was hoping that TU58FS could do that, but I'm like 90% certain that it can't. Talking around with the people on the Discord, we think we found a utility, but that's gonna take sitting down and a couple of days of trying to figure it out and see if we can get real data, real tape images from the laptop onto little tapes like this. So that's something that we'll tackle in the next episode. It's getting awfully late here, but I consider today to be a victory. Not only do we have a functioning TU58, a functioning TU58 emulator, the panel here came out looking absolutely beautiful. Finally we got a win, even though it was a small one. So I want to thank you all so much for watching, and I hope to catch you in the next one.